Welcome. In this session, we'll solve problems based on the previous sessions. How do we calculate the complex power if voltage and current are given to us? Okay, so let's suppose the voltage across the element is V, and this is given by 5 at an angle of 40 degree, and the current through the element is simply given by, so these are given in terms of phasor values. So this is the current, and remember these are the RMS values. So we say this is the, let me rewrite this. So we say this is 5 volts and this is RMS. Okay, means RMS value of the voltage is given, and the current is simply 2 at an angle of minus 20 degree, and again this is the measured in amperes, and this is the RMS value of the current. Okay, so our goal is to find S of the element, whether this is a source or the passive element. So if this is a source, what is the complex power supplied by the element? Okay, so we have to get find the complex power supplied consumed by the element, or we have to find the real power supplied or absorbed by the element. Reactive power and apparent power of this element, and also power factor. We have to also find the power factor. Okay, this is what we have to do. So how do we define the complex power? First of all, so complex power is denoted simply by S. So complex power is denoted by the letter S, and we know S is defined as V times I phasor if the RMS values of the quantities are given. This is very, very important. So you must note down this. So if RMS values are given, it is simply V times I conjugate. So how much is the value of V? It is 5 at an angle of 40. So this will be simply 5 at an angle of 40 times 2 at an angle of minus 20. So when you take the conjugate of this, it will be plus 20. Okay. So if you multiply this, this will be simply 5 2s are 10 at an angle of 40 plus 20. So angle is add. And the magnitude part is multiplied, angle is simply add. Okay, this comes from the De Moivre's theorem in the complex algebra. So this is simply 10 at an angle of 60 degrees. Now you know we can simply write it as 10 cos 60 degrees plus j 10 sine 60 degrees. So we can express this polar form as in the rectangle form by simply multiplying the 10 with cos 60 degree plus j 10 sine 60 degrees. Okay, this is how we convert polar form to the rectangular form. Very simple. Okay, so this will be simply, what is the value of cos 60? Cos 60 is 1 by 2. So it will be 5 plus j 10 sine 60. Sine 60 is 0.866. So that will be 8.66. Okay, so this is the value of the complex power, and it is denoted by V. So what's apparent power here? So if we have to define the apparent power, so first of all, let us get the apparent power. Apparent power means simply magnitude of S. Okay, magnitude of S is simply, you can take it will be 5 square plus 8.66 square. That will be simply the magnitude of this will be, so this is 25 plus 8.66. So this will be roughly around 8.66 square. So that will be, now if you calculate, it will be around 10. Now if you do the square of this, it will be roughly around, it will be equal to 10. As you can see, the magnitude is 10. So magnitude is simply 10. So if you take the square of this, then take the under root, you will get this. This will be equal to 10. And this, the unit of this is simply VA. Okay, volt amperes. All right, it is measured in VA. Now, What is the real power? Real power, as you know, is called the real part of this. So real part is simply, so P is simply equal to 5, and it is denoted in watts. Okay, P is measured in watts. So this is the power consumed, or average power consumed, are supplied by this element. Okay, that has voltage equal to 5 at an angle of 40 degree. Current is equal to 2 at an angle of minus 20 degree. Okay. Now, what is the reactive power absorbed by the element or supplied by the element? As we don't know whether the element is supplying or consuming the power. So it is the imaginary part of this. So that's equal to, so that's denoted by Q. Q is equal to 8.66, and it is denoted by VA, volt ampere reactive. So we have calculated the complex power, real power, reactive power, and apparent power. Now we'll calculate the power factor. So power factor is simply given by, denoted by PF. So it is simply given by PF is equal to P divided by S. I mean the magnitudes here. So P is 5, S is 10, so it will be 0.5. Now you can see the this power factor is also denoted by cosine of this angle, whatever is the angle in S. So it is denoted by. So you can check from power factor. If you calculate it from that, power factor is simply cosine of 60 degrees. What is cos 60 degrees? It is 0.5. So whether you use this calculation or this approach, one and the same, the answer will be. Okay, so this is how we calculate the complex power, reactive power of an element if we know the voltage phasor and current phasor. Okay, now if V and I were in maximum values, so if the maximum or the peak value of these quantities were given, so you have to take S as V times I phasor divided by 2. Please remember this. So this is very, very important for, especially for GATE exam. Now GATE exam uses one notation. The book that I have recommended, that's Alexandros Sartikos, uses another notation. So whether you must consider whether the values are given in RMS values or peak values. So if these are given in peak values, you will use this expression. If these are given in RMS values, you will use this expression. Okay, so please note this. All right. So in the next session, we will solve some more examples based on this power.